Let's solve this problem about function composition and inverse functions step by step. We're given two functions, f of x equals 3x squared over 4x minus 1, and g of x equals 1 over x squared. Both functions are defined for x less than 0. Let's start with part A, explaining why the function fg does not exist. Remember, when we compose functions, we first apply g, then apply f to the result. Let's visualize this process. Here's why fg doesn't exist. When we apply g first, the output is always 1 over x squared. Since x is negative, 1 over x squared is always positive. But f is only defined for negative inputs. Therefore, we can never apply f to the output of g, making fg undefined. Now let's solve part B, finding an expression for gf of x. First, we apply f of x, which gives us 3x squared over 4x minus 1. Then we apply g to this result. Remember, g of x is 1 over x squared, so we need to square the denominator of f of x and put 1 over it. Let's simplify this expression. First, we square the fraction in the denominator, then multiply by the reciprocal. Our final simplified expression for gf of x is 16x squared minus 8x plus 1, all over 9x to the fourth power. Finally, let's tackle part C, finding f inverse of x. To find the inverse function, we first replace f of x with y. Then we solve for x in terms of y, and finally replace y with x. Let's work through this step by step. Now, we can use the quadratic formula to solve for x. This gives us x equals 2y plus or minus the square root of 4, y squared minus 3y, all over 3. Since we know x must be negative, we take the negative root. Finally, replacing y with x, we get f inverse of x equals 2x minus the square root of x times 4x minus 3, all over 3. Therefore, comparing with the given form, we can conclude that p equals 2, q equals 4, and r equals negative 3.